are all familiar with hacking and its dramatic and costly impact on businesses and individuals. But have you ever seen a live hack before? Well, you're about to. With IT across all parts of our private and working lives, the scale of IT components connectivity is increasing at an explosive rate, and consequently severely extending the chances of falling victim to an attack. According to our next speaker, today's connected world is a scenario hackers have been dreaming of. Sebastian Schreiber is the founder and CEO of SySS GmbH. A computer scientist by trade, Sebastian set up the business in 1998 to offer high-quality security assessments, and today employs a team of 160 people, of which 110 are solely occupied with security and penetration testing on behalf of all kinds and sizes of companies. Importantly, SySS is product independent in order to guarantee an objective provision of service. Working in a consultancy role, the company's sole focus is to help customers increase the sustainability of their IT security. So let's find out more now, and welcome Sebastian Schreiber.
So, thanks a lot. I'm very happy to be here and to demonstrate a lot of attacks. This list of attacks that I brought with me, so all the things on my table, including the hairdryer, are part of the demo. These are tools that I'll hack and tools that I'll use in order to perform attacks. So I got a huge amount of attacks that I can demonstrate. The first attack is an attack against a smart thermostat. Against this one. This controls the temperature, maybe in your living room, or also the temperature in critical areas such as nuclear power plants. This smart thermostat has a battery inside and controls via radio this power plug. And this power plug decides if the ventilator starts or not. And we will perform the attack against the radio connection using a so-called software-defined radio. I got 3 software-defined radios with me. The first one is this one. This is too small. That's very cheap. Costs only $18 US. It's not mighty enough in order to perform the attack. This is the big brother. It's a Hack RF. The small one is called Crazy Radio, and I will use this tool in order to manipulate the radio communication. And the software that I'm going to use in order to perform the attack is very easy to write. It's so-called software-defined radio. And this is the piece of software. You can use your mouse and you can click the software together, so it's very easy to perform the attack. So as soon as I press the green button, this piece of software will be compiled and will be uploaded to the SDR. The SDR will start the attack and will influence the communication between smart thermostat and the power supply. And as a reaction, you will see that the hairdryer, I was not able to take a cooling tower or things like that with me. So you will see the reaction quite soon. 1, 2, 3. You see the software is compiled. It's uploaded. And you see the hairdryer is switched on. Seconds later, it's switched off. And seconds later, it will be switched on again. And now I'll stop the attack. Yeah, well, as you've seen, I'm able to manipulate the radio communication, and as you've seen, I decided to switch the product on and off all the time. Can you imagine why I'm switching on the hairdryer, switching it on and off all the time? To kill it, right, exactly. This method was invented during the so-called Stuxnet attack. The Stuxnet attack was done as a cooperation from 2 secret services in order to sabotage centrifuges that produce material for nuclear bombs. And exactly that was the same attack that I wanted to do here with the software-defined radio. So please be careful. Wherever you use radio waves are easy to manipulate. The protocols are often implemented weakly, so we are often able to perform the attacks without any problems. So let's go to the next attack. The next attack is completely different. It's an attack against a crypto USB stick, and I will take this one. It's the black one at the left side, and you see there's a USB-C adapter, and you can store your secret information on this USB device, and the information are protected by a 12-digit PIN. So you can choose a 12-digit code. How do you feel when you hear 12-digit passcode? Yeah, right, 12-digit sounds quite good, as for example, the passcode of my smartphone is shorter, and the passcode of my luggage is also shorter. It comes with 3-digit, and obviously 12 is much more than 3, so it seems to us like a 12-digit code is more than enough. Of course, you can try to enumerate the code. You can start by 12 times the 0, and you can count up to 12 times the 9, but this is time-consuming. And the vendor tries to prevent this attack to be successful. That means if you type in the wrong code for 10 times, then the stick will be locked for a whole hour. The day has 24 hours. That means you are able to try only 240 PINs per day. That's not enough to perform an efficient attack. So what we did, we tried to do a completely different attack. What I did in the morning, I opened the screws, so I'm able to open this device. Please take a look. If I tap in this direction, then I can just open it. This is just the lid. I can put it on the table, and you see this here it's the power bank. And I can take out the power bank easy like this. Whoops. And now I get a completely different situation. The mechanism that locks the stick for the whole hour after 10 times a wrong PIM is presented is here. It doesn't cause problems during my attack. So I can concentrate on this device. It's just memory, zeros and ones, and I can try to do the attack, but I got a new problem. If I hand this piece to you and I tell you the code is 1, 2, 3, 4, 5, 6, 7, then you are still not able to decrypt it, as you do not know how the key is generated from the code, and you do not know which crypto algorithm is used. That's what my experts in our lab, we got a TSAC certified embedded pen testing lab in Tübingen. Tübingen is my hometown, it's in the southern part of Germany. We were able to reverse engineer the stick, so we are able to perform the enumeration attack. In order to do the attack, I need this little device. So I can put the memory in. Okay, looks good. And I need this USB-C cable, and I'm using the cable that is connected to my laptop, and I will plug it in here. Fine, so this looks good, and now we need our hacker software. First, I need a command shell, cmd.exe. I have to start it in admin mode because I need raw access to the bits and bytes. Accept it with return. Now let's go to my hacker tools. And I start the attack, and now the attack is running. The vendor claims that we can just do 240 attacks per day. Guess how many attacks I can do per day? Or guess how many attacks I can do per second? Unlimited is not right. There is a limit. Any ideas? Attacks per second? Guesses per second? 1 million, yeah, it's close to 1 million. So we just let the attack running, and we will take a look at the next attack. And the nice thing is, attackers can perform their work in parallel. Fine, let's go to the agenda again. And the next attack is also interesting. It's an attack against a paywall. Everybody knows that firewalls can be pierced. At the moment, there are severe problems with a firewall from Check Point. So if you run a Check Point firewall, maybe exactly now attackers will get through your firewall into your corporate network. But we won't perform the attack against the firewall right now. We will perform the attack against the paywall. Paywall of a big German newspaper. It's the FAZ. It's a very well-known, very big German newspaper. Huh? Bit strange. Seems like I'm not able to start Chromie. I'm not hacked. No. I think it has to do, it's because the attack against the USB drive is quite time consuming. Okay, something is happening. Yeah, that's Chromie. Okay, let's go to the faz.net. It's a German newspaper, it's an important German newspaper, and some of the articles are behind the paywall. You have to pay to access the articles, and other articles are free. We will see that, of course, we will perform the attack against the pay articles, and they are tagged with the F+. For example, this article is behind the paywall, and as I did not log in, I'm not allowed to access the article. That means when I click on the article, you see something is downloaded, and the start of the article is downloaded. I can start reading, and seconds later, you see the article stops, and the FAZ tries to sell me a plan, which is quite cheap, and then it becomes expensive after, for example, something like 3 months. Fine, what we did is we wrote a short tool. It is this one. It's our FAZ Premiumizer, and this tool pierces the paywall. No, I can't sell you the tool, and I can't give you the tool. It's not legal. And before I'm doing this presentation in Amsterdam, of course, I informed the FAZ. I sent them an email. Look, you got a security problem in your web application, and they sent us a letter which contained the word thanks very often, but they didn't fix the vulnerability. Fine, so we go to the unlock button, 1, 2, 3. You see, we got a success. Enjoy reading. We click on OK, and you see, whoops, we can read the whole article without having to pay for it. The paywalls are typically implemented very weak, so it's very easy for us to pierce them, and it seems to me like the big newspapers are not interested in fixing the problems. Fine, so let's have a look at the tool that is just doing the enumeration attack. It's still running, so we can do something else in the meanwhile. Let's have a look at the agenda. I also like to show you that it's quite easy to perform attacks against wireless keyboards. I'm pretty sure that lots of people in the room use wireless keyboards. This is a German manufacturer, it's called Cherry, but maybe you use the Logitech keyboard or other keyboards, and I have to tell you that most of them are not secured at all. Some of them are secured, like this one. If you take a very close look to this part of the keyboard, you will see the word AES security. So the vendor claims that the transmission between keyboard and PC is encrypted with the AES algorithm. That's right, but the implementation is so weak that we are able to break it. Fine. By the way, we did this project for the German Federal Bank. They asked us to perform penetration tests against a series of wireless keyboards, and we've been able to compromise lots of them. Fine. And it's very comfortable for a hacker. We don't have problems with firewall, antivirus, login ID, passwords. If you are using a wireless keyboard and I hack the keyboard, then I can become you. And all the commands that are typed in are executed because the PC thinks, oh, it's you who typed in the commands, so the commands are executed with your rights. All the things that you are allowed to do, your keyboard is also allowed to do. So it's very attractive for us to perform those attacks, especially if we are doing so-called red teaming projects. My company is specialized in doing penetration tests, and red teaming penetration tests are special penetration tests in which we are allowed to perform very aggressive attacks, and such an attack might be to own the wireless keyboards in your company and then to send commands to your PCs. So I can Trojanize all your PCs and I can own your whole network, your whole IT infrastructure. And when I own all your clients and all your servers, then I also own your company. Fine, so let's start with a target system. Victims always work with Windows, but the attack is against the keyboard, so I can attack Windows, Linux, all kind of operation systems. So the attack is against the keyboard. After that, I need the software-defined radio that I showed you beforehand. As I told you, only $18. So it's a very cheap attack. And if the attack is very cheap, then the risk is quite high, as everybody can do the attack. I connect the crazy radio SDR with my Raspberry Pi, and of course I need electricity, so I'm using my power bank. And now a short Linux operation system is started on this Raspberry Pi. You see, there are 3 attack buttons on the Raspberry Pi. That means I'm going to demonstrate 3 attacks. Fine, we have to wait some seconds until the Linux is booted up. In the meanwhile, we'll check the USB drive. And we see the attack is finished. You see, that's the PIN code. I set a 10-digit PIN code. And I'm very proud of my employees. In this time, it's Matthias who wrote the tool for me. We're able to try 22 million guesses per second. That means in below 12 hours, I'm able to try all possible 12-digit PINs. So if you're using this device, it takes only something like 11 hours, and then I'm able to tell you your PIN and to access all your personal data. So it's quite important not to trust what the vendor tells you. It's important to perform own tests so you can find out whether USB storage is secure or not. Fine. Fine. Now the Linux system is starting here, is running here, and I will type in the password on this virtual machine. Right mouse button, we're going to abmelden, which means log off. Now I'm starting the attack by pressing the first attack button. First I have to switch on the keyboard. It's switched. No, whoa, lots of things are missing. I didn't prepare it. I have to plug in the USB. So now I can type in off on. Okay, looks good. So Now I can start the attack by pressing the first attack button, and now it says recording the hacking device, and now I can type in the password using the wireless keyboard. I'm stopping recording. Now I log off again, right mouse button, we're going to log off. And now I'm pressing the second attack button. 1, 2, 3, the attack is running. Oh no, didn't work. Let's try it again. Something went wrong. Okay, first button, it says recording. Stop recording. Let's try it again. Right mouse button. Oh no, wrong command. But the PC is quite fast. It's very important that the attack works, because I also wanted to show you the third attack button. So now the second attack button. 1, 2, 3. Ha! It worked. You've seen that I was able to represent the password. I can also show you what the password is. I'm typing the second attack button, and you see, whoops, the password is lifehack. Fine, now let's talk about the most powerful attack button. It's the third one. The third one will use the radio connection between keyboard and PC in order to Trojanize the target system. 1, 2, 3. And you see that a command is inserted and sent to the PC. Now payload has been downloaded, and now the system is Trojanized. That means now I can access the system through a firewall from everywhere, all over the world. What can the attacker do? The attacker can use this little Raspberry Pi with a software-defined radio, with our software, and can put it in a backpack. The attacker can take a walk through Amsterdam, and wherever the attacker sees radio communication from Cherry keyboards or Logitech keyboards, the hacker can Trojanize the target system. After having a 3 hours walk, the attacker goes back to his hotel room and checks which system the attacker called. After that, the hacker will do something like lateral movement on the systems that the attacker compromised, and privilege escalation. Privilege escalation means always getting whole access to the Active Directory. After that, the attacker starts encrypting all the system to which the attacker has access. Crypto ransomware attacks are very dangerous in 2024. After all your systems are attacked, you will get ransom notes. Please give me 10 bitcoins, and then I will give you the key with which you can decrypt your systems. Crypto ransomware is very dangerous this year. Fine, so take care with wireless keyboards. Please take also care with wireless mice. We can also use the connection between your wireless mouse and your PC in order to send commands to your PC. And there's something that's much more dangerous. It's the Logitech presenter. Never ever touch this device. If we perform attacks against the wireless keyboard, I have to send my specialist to you. You will meet the best cybersecurity consultants, the best hackers, the best penetration testers. If you want us to attack systems that use the Logitech presenter, then I will send you my trainees, because they will be able to compromise your network within hours. As this system is encrypted with the AES, which is a quite powerful crypto algorithm, this system is not encrypted at all. That means it's very, very, very easy for me to break into the networks. I just have to use this device. I will identify the connection, and then I can start sending commands to the victim's system without breaking encryption, and as there is none. And that's, by the way, a very typical situation for the penetration tester. The penetration tester does not always search for so-called OD exploits, exploits that nobody else knows. Quite typically, the penetration tester's job is to identify the parts of your company infrastructure that are not secured at all. The parts in which somebody has forgotten something, such as setting up a password, changing the default password, or switching off services and things like that. Fine, so let's take a look at the agenda again. The next attack is the attack against the other USB device, which is the USB stick at the right-hand side. I got it here. You see, it's the same vendor. Both are from Verbatim, and both are very easy to attack. The right one is called Executive Drive, maybe because of executives are not able to remember PIN codes. So they might prefer here the fingerprint. Fine, so let's connect this USB drive with my laptop again. You see there's an LED that is red, and after I present my right fingerprint, my right thumb, then the red light will become green. A file system is presented to the laptop, and then you can access the data. It's very easy. It's also very comfortable, as you can use this in the office, at home, and also on your Linux system or on your Apple system. You do not have to start software, you do not have to install software, so it seems to be quite flexible and quite comfortable. But if you learn, if you force the system to learn your fingerprint, you have to press your fingerprint 10 times on the sensor, and you have also to set up a so-called recovery key, because you might injure your fingerprint, for example, during sports or things like that, and it would be a pity if you store all your money in bitcoins on the USB drive, and then something happens with your right thumb, and then all your money is gone. That's not a good idea. So the vendor, the product, forces you to set up a recovery password. And we find out that that the recovery password is stored on the executive drive, and we also found out that we are able to extract this password using one of our hacker tools. That's the hacker tool. I just have to press retrieve password, and then we are able to force the device to send us the password. 1, 2, 3. Look, the password is lifehack. I always take the same password on my demos. Yeah, so that's a catastrophe for the vendor, because everybody who is in crypto knows that you are not allowed to store passwords on the device. You are not allowed to maintain clear text passwords. The vendor also knows, oh, that's not a very good idea, so they obfuscate the situation. The stick does not send the plain text password to the PC, it sends an obfuscated password. And it also doesn't send the obfuscation password as a whole, it sends it character by character. But my experts were able to decrypt the password and to present it. Last year, in August, I received a phone call from the Federal Police of Austria. They were able to get lots of encrypted USB drives. So the criminals in Austria, some of the criminals in Austria also need a supply chain and lists and affiliates and conditions and so on, and they were using those devices, a bunch of those devices, in order to keep their data secret. And I was able to send one of my employees. I got a Vienna office to the federal police in Vienna, and Michael, my employee in Austria, was able to crack all the criminals' USB drives without seconds. Fine. Now there's something in the room. There's a big question in the room. So it seems like we discovered a vulnerability. Seems like the software developers made mistakes, and that's why we are able to decrypt the data on this USB drive and this USB drive. 8 years ago, we were able to perform attacks against this USB drive. It's also an encrypted USB drive, and it's from the same vendor. So, maybe the company verbatim hires the worst possible software engineers, and these software engineers do not care about IT security, although they implement crypto algorithms. That's possible. But something else is possible. Maybe we discovered backdoors, and maybe the company verbatim always implements backdoors in their crypto products. Maybe because of compliance reasons, maybe they want to sell their products in countries in which they are forced to implement backdoors. I can't tell you. I can't tell you if we just discovered mistakes or we discovered backdoors. I can't tell you. Typically, we do something like responsible disclosure before I do demos on stages like this. Of course, we contact the vendor and verbatim refuse to communicate with us. That's very unusual. Typically, the vendors in which we discover vulnerabilities, they want to find out how to fix it, or they want us to postpone the date of disclosure by 2 months or things like that, and verbatim didn't react at all. By the way, last year we discovered vulnerabilities in the video conferencing system Zoom. So we were invited to the Black Hat conference, which is one of the world's biggest hacker conventions in Las Vegas. This year we will also speak in Las Vegas on the DEF CON conference. My employee Moritz will go there, but I'm not allowed to tell you what's his topic. It's also something hot. Fine, so let's take a look at the agenda, and it seems like I was able to demonstrate all the attacks. First, we started with the attack against the smart thermostat. No, the web shop hacking. We forgot the web shop hacking. We forgot B. C, of course, we did the attack against the USB drive with the PIN. We did the firewall piercing, paywall piercing with the FAZ. We did the attack against the crypto storage with the fingerprint reader. And of course, we did the attack against wireless keyboards, but it seems like we forgot to perform the attack against the web application. So let's do it. It's also quite nice. You see, that's a bookshop. Have to accept cookies, and we can choose a topic. What kind of books do we want to read? We are interested in Völkerkunde, Orientalistik, and Ägyptologie. Okay, and you see, we can buy lots of books. Let's have a look at the second book. It says, Die spätbronzezeitlichen Palastanlagen. And you see, the book is sold for 99 euros, including tax. Now I will use my mouse pointer and move it to the shopping cart symbol. And if you got good eyes, then you will see exactly here, this part of the link contains the price. So the information about the price of the product is implemented in the hyperlink. Right mouse button, we go to copy link location. I'm just starting WinWord so you can see the whole hyperlink. Look, if you take a look at this part of the hyperlink, the red part, you see the prices included in the URL line, and I'm pretty sure that everybody in this room knows what's next. So, Control V, we go to the price information. 99 euros, we reduce it, for example, to 12 euros, and now we press return. And we see, boing, didn't work. We got an error message which says hash comparison failed. So the software developers of this web application knew, oh, it's not a good idea to transport the price in the URL. How can we fix the problem? We can fix the problem by digitally signing the URL with a hash code. And that's very typical. The penetration tester fails all the time until the penetration tester is successful. So it's asymmetric. We as the attacker are used to fail. It's okay for us to fail the whole day, to fail 100 of times. It's enough to be successful one time. It's your job to defend your company. So 99% is not good enough. So if you're responsible for a submarine, it's not enough to close most of the windows, you have to close all of them. Fine, so any ideas? How can we fix this? How can we sabotage the hash comparison? Any ideas? I want to sabotage the hash comparison so this request is accepted. Look, this is the hash, C hash. How can, any ideas? Also possible, we can try to recalculate the hash, that's not so simple. The attack is very simple. I want to sabotage the hash comparison by eliminating the hash. So let's go to the browser again. Control V. We eliminate the hash just by pressing backspace. Whoops, now we go to the information about the price, 99 euros. We will reduce it to 33 euros, that's fair. We will press return, and you see, whoops, it worked. I can put the product for 33 euros, thanks a lot, in my shopping cart. Fine, so it seems my time is over, and I'm very happy that I was able to perform all 6 attacks.
Sebastian, thank you so much for that fascinating.
Yes, you're welcome.
And some interesting tips there. Just time for a couple of quick questions. Maybe just before we go, if you had 3 top tips to leave companies with on how to improve their IT security, what would those 3 things be?
I think the major risk in 2024 are the crypto ransomware attacks. So please perform real penetration tests against your systems. The crypto ransomware attacks are very painful, are very cost incentive. So please perform penetration tests. If you're interested, my company offers penetration tests. Just contact me. I got no, I don't have. I think I've got the contact information at the last slide of my presentation. Fine, so penetration tests are important. The second measure is please prepare incidents. Penetration tests will secure your network, but you won't be able to get 100% security. So it makes sense to be prepared to do tabletop exercises. Check your backups is very important. And the third one is please invest in security awareness of your employees. Do simulated phishing attacks. Do security awareness talks and things in your company. So these are the 3 things. Penetration tests, something like incident response readiness, and security awareness.
And just in one sentence, probably difficult to summarize, but what would you say are the trends that we need to be looking out for in the near future?
The biggest trend is that the hackers become more efficient. The hackers act like companies. They got contracts, they got affiliates, they got business processes. So hackers develop like companies because doing the attacks is so attractive. The criminals get so much money at a minimum risk, and that's new. So invest more money in cybersecurity.
Sebastian, on that note, thank you so much again for joining us. Thank you.
Thanks a lot. Thanks a lot.